All right, let's continue with an example. So, example number 1. Let f of x be equal to square root of 4, square root of x minus 4. We want to find two things. Number 1, what is the value of f inverse of x when x equals 2, and B, we want to find out what is the value of the derivative of f when x equals 2. Well, first of all, let's talk a little bit about this particular function. This is a radical function and is defined for all values for which x is bigger than or equal to 4. We could check that. The domain of this is x minus 4 bigger than or equal to 0, so you add 4 on both sides. So that's the domain of this function. So this function is indeed differentiable on an interval, and this particular interval would be 4 to plus infinity. Now we just have to verify that we have an inverse. So if you remember from pre-calculus, to find the inverse of a function, we first rewrote the function as y equals the function, and then we switched the variables. So we switch the x and the y, and then we solve for y. So to solve for y here, we will square both sides. We have x squared equals to y minus 4, and then we add 4 on both sides. We have x squared plus 4 equals y. So this is the value of f inverse. Now, first question is, what is the actual value of f inverse when x equals 2? And to figure that out, we simply plug in 2 for f inverse, but f inverse is x squared plus 4. So there's going to be 2 squared plus 4, which is 4 plus 4, which is 8. Now, what is the value of f inverse prime of the derivative when x equals 2? Okay, so for this particular function, it is actually quite easy for us to take the derivative and then just plug in. But for the sake of argument, and to use the theorem, let's apply it. Let's apply theorem. And remember, the theorem says, let me rewrite it, that g inverse of x, or g prime of x, g is f inverse, is equal to 1 over f prime evaluated at g of x. And here g of x is the inverse of f. Well, following the formula, we have 1 over, well, what is the derivative of f prime? Well, f prime is the derivative of y equals square root of x minus 4. So let's figure it out. Let's figure out what that is. So f of x was given to be radical x minus 4. That means that f prime, by the general power rule, is equal to, and by the way, remember we could rewrite this as x minus 4 to the 1/2. So it's equal to 1/2 x to the minus 4 to the minus 1/2 times the derivative of the inside, but by the chain rule, but the derivative of the inside is just 1. So this is simply 1 over 2 times the square root of x minus 4. That's what the derivative of f is. So we have f prime, which is now 2 radical x minus 4. But remember, we are evaluating f prime at g of x, and g of x is x squared plus 4 from up here. So we have x squared plus 4 minus 4. So this x squared plus 4 is being substituted in for this single x right here. And then we still have the minus 4 being carried over. And now, this is what the derivative of g prime of x will be. And now we simply have to evaluate it at the value given, which was 2. So g prime of x is going to be equal to 1 over 2 times the square root of, and we were evaluating this at x equals 2. So it's going to be 2 squared plus 4. 2 squared plus 4 minus 4, which means we have g prime of x is equal to 1 over 2 times the square root of, well, 4 plus 4 is 8, minus 4, which is 1 over 2 times square root of 4, which equals 1 over 2 times 2, which equals 1 over 4. So the derivative of f inverse for this particular function evaluated at 2 is equal to 1 over 4. Okay? All right. So let's do another example. We're going to do a couple more examples, and actually, basically, the rest of the lecture will just be examples. There's nothing new to do. It's just applications of the formula. Now, something that is of importance is that the graph of inverse functions have reciprocal slopes, meaning that if the slope of the first function is a over b, then the slope of the second function, if they're inverses of one another, at that same point is going to be b over a. So that's something that's important to know. So let's do an example that will illustrate this. Let f of x equals x squared for x being bigger than or equal to 0, and let the inverse of f be equal to the positive square root of x. The question that we have to do, that we have to worry about here, is to show that the slopes of the graphs of f and f prime are reciprocal of each other at the points 2, 4 and 4, 2. So first of all, let's talk about f of x, which we said was x squared, and f inverse of x, which we said was square root of x. We know from the formula, that g prime of x is going to be equal to 1 over f prime evaluated at g of x. That we know. However, we do not know what f prime is. We have not calculated that. So let's actually calculate it. F prime is the derivative of this first function, so f prime of x is equal to simply 2x. Now we can actually simplify this. We know what g of x is. G of x is f inverse of x. So if we simplify this a little bit, we get 1 over f prime, which is 2x, evaluated at g of x, which is radical x. So what we get is 2 times square root of x, where the 2 is coming from this function, and the radical x is being substituted into this x from here. Okay, so that's what the derivative is. And now if we evaluate that derivative at the point x equals 2, right up here, we get that g prime of x is equal to 1 over 2 times the square root of 2. Okay. Now, whoa. Whoa. Yeah, no, I have a mistake here. I evaluated the wrong point. This point corresponds to the first function, and this point corresponds to the second function. So I should be evaluating the derivative at 4, not at 2. Because I'm doing the inverse first. So if we evaluate the derivative of the inverse function at 4, then we get 1 over 2 times 2, which is 4. So we get 1 over 4. And then if we evaluate f prime, this now makes sense, because I have to get the slope of the first one at 2. Then we have 2 times 2, which is 4. And lo and behold, 4, its reciprocal, is 1 over 4. And the other way would have worked out okay as well. Meaning, if I do it the other way with 4, I would still have gotten the reciprocal. But that's not what I had in mind. Anyway, that's how you'll do a problem like this. You could do another problem. I'll leave it as an exercise. Do the same steps for the points 3, 9 and 9, 3 with the same function. So you literally just have to figure out what f prime of 3 is, and then what g prime of 9 is. And they should be equal. I mean, they will be equal. We just have to show that. Right, so I'm going to end this video here because the next piece is going to deal with trigonometric functions.